Yeah, I don't know if you're going to go into it anymore in part 2, but why do we need Anaconda and Spider and everything also for Python? Or you're going to go there in second part?
I think I'm not. I should check actually.
Yeah.
I think I put that somewhere. But I can also tell that right now it doesn't really make that much of a difference. So that is indeed a question that a lot of people that just start programming, and especially at TU Eindhoven, I heard this question a lot because for some reason everybody at TU Eindhoven decides to install Anaconda and chooses Spider as its IDE. I think that just kind of grew in there, and they just, whenever you try to install something, you just ask someone that has already done it, and he just tells you what he did, and everybody just does the same thing. But so for Python, you have to install a lot of packages, and if you have used this before, you probably have seen pip install blah blah blah. So you can install any package using pip. So pip is a package manager. So it knows about a lot of standard packages that are in some online environment. No, I shouldn't call it environment. In some online database, they are present. And if you say pip install package name, it searches for that package name in this online environment and pulls it to your computer. And for a lot of Python projects, you need a lot of different of these packages. And some of these packages are in conflict with one another. So if you have package A, but it doesn't work with package B, you've got a problem. So you need to remove package B, for instance, so that you can use package A again. But if you have a lot of different Python projects on your computer that need different packages, it becomes a problem because for one project you would need package A, and for the other project you would need package B. And if these two are in conflict, you would constantly have to deinstall and install these packages. So what Anaconda basically does for you, it says like, okay, we can create virtual environments where we can install these packages. So you create a virtual environment where you build your Python project and you install the packages with pip you need there. And then if you build a different Python project, you just create a new virtual environment and pull the packages that you need for that project. And these two environments, they don't know about the packages that exist in the other environment, and therefore these conflicts cannot exist. But having said that, like most people, most students don't have like hundreds of Python projects on their computer with even thousands of packages. So I think it's most of the time a bit overkill to use Anaconda, but it cannot hurt either. So, and for Spider, I think it just, I've never used Spider myself, but I think it's quite a useful IDE. So an IDE is basically a program which has a lot of tools that help you make programming easier. So, for instance, did I close it? No, wait a second. So, as I showed here, this is just a plain text editor that everybody has on their computer. And if I create a variable here, x is 1, x is 1, I say y is, let's make this a more complicated variable. So this is my variable. And I define y, which is equal to this is my variable divided by 2, for instance. I can execute this code, and then we have this is my variable is equal to 1, and y is equal to 1 divided by 2. But if I would have a lot of code, and later on I would want to reuse this variable, I would have to check like what is this variable, what was the name again of this variable, and if I have to type it constantly, I can make spelling errors, and which gives compiling errors and stuff. So what an IDE does for you, and I can show that here because this is an IDE that I use myself. So if I create, let's see, no, if I create a variable here, test is 1, and say result is test, it already presents test here to me. So I know this variable exists and I can just add it here. So a lot of IDEs have these tools that make it easier to program. They also point to syntax errors you make and stuff like that. And Spider is just one IDE you could use. And I think it's quite intuitive, and therefore it kind of looks like MATLAB, I think. So that's why a lot of students like to use it. But to come to the basics of it, sorry for this long answer to your question. If you would want to program with Python, you would only need to install Python. You don't need anything else. The other ones are just tools that make your life easier. So we can start with the second part of the course, which I think is what most people came for, which is an introduction to Python. So sorry for the extended introduction to what programming is, but I always feel like it's important for someone that starts to learn programming to have a bit of background in what programming actually is and what your computer does. It might be less interesting, but I think it's good information to know. So to get to the second part, Python for beginners. I want to start off with this meme that I found. I hope this doesn't discourage anyone. But learning a new programming language often feels like climbing on a steep hill. And then once you think you're finally there, it turns out there's a whole lump left that you never heard of. And my goal for today is basically to help you guys over the first lump, and then from there you can climb on yourself, hopefully. But it feels like it's a tragic journey, but it's also a fun journey. So I hope this doesn't discourage anyone. So first, data types in Python. So I just told you guys what a compiler does. So it translates your code to ones and zeros. So if a compiler can translate everything to ones and zeros, why do we need data types? So data types are, you might have heard of integers and booleans, floats, stuff like that. So why do we need to know what an integer is and what a string is if the compiler converts it to ones and zeros anyway? It's because data types, the compiler does a lot more, but it also needs to know what you as a user plan on doing with the data you created. So if you created an integer and you added a string to it, it wouldn't make any sense. It could convert that to ones and zeros, but you would never get the result you wanted because you're just making a mistake. So every data type has its rules. The interpreter checks whether you apply to these rules, and if you don't, it will give an error. So what data types do we have in Python? So there's a couple of built-in data types, and I basically grouped them in these categories. So for text, we use strings, which in Python is str. For numerics, just for numbers, we use ints, floats, and complex, where ints are integers, so whole numbers, 1, 0, 3, 4, etc. And floats are decimal numbers. And complex, well, as the name implies, are complex numbers. Sorry, dry throat. Not used to talking this much. For sequences, we use lists and tuples. And what the differences between these are, I will show you in a slide later on. So a sequence is basically assigning a set of data to a single variable. Then for mapping, we use dictionaries. So in short, These are dicts. What that means is you can map a value to another value. So you can, these are key value pairs. That's what they are called in Python. But you can map a string to a value. This all sounds very vague, but I'm going to give examples for all these things, so don't worry. Same holds for sets. Also, a set of variables, values, sorry, that you can assign to a single variable. And then we have Booleans. Booleans are either true or false. So these are already just ones and zeros that your computer can understand. And finally, we have binaries. So bytes, byte arrays, and memory view. These are way less important than you're probably never going to touch them anyway. So I'm just going to go over the most common data types, which are the following. The string, integer, float, list, dict, and bool. And for these sequences and mapping, sorry about that. Lists we create using square brackets, and dicts we create using curly brackets. So that's already a difference between them that you can see here. But there's many more differences between these sequences. So the way they're initialized, so lists, as I mentioned, are with square brackets, dicts with curly brackets, sets also with curly brackets, and tuples with parentheses. But differences are in whether they are ordered, whether you can change them, and whether they allow for duplicates for more than, so for the same value twice or more in that list. So a list is always ordered, and you can change it, and it allows duplicates. So it's the most generally used type of sequence. So this is what will work with the most. Second, we would have dictionaries. So I actually put these in order of how common they are, so how often you will probably use them. So lists are very, very common. Dicts a bit less, but still very common, and these two are actually way less common. So dictionaries are ordered as well since Python 3.7, but it doesn't really matter. That's what we're going to use anyway. You can change them, but they don't allow for duplicates. And I'm not going into these two that much because I don't think it's that relevant, because these two are just the most common ones that we'll use. So let me, let's see, put in some, use my IDE here. So this is a list I created. So I can already see how we can instantiate a list using these square brackets. So I can now print out this list. And oh, sorry about that. My list. And you can see it prints these numbers that we put in there. There's some couple of things you can do with lists. Well, there's a lot of things you can do with lists, but we're going to go over a couple of things you can do with lists. So first off, we can append numbers to a list. So in this case, let's say 4, and then we print my list again. So as you can see, first we had these numbers in there, and then I appended the number 4, and it got appended to the end of the list. We can also do my list. We can also use pop, which is a function that removes the last item from the list. So print my list, and we're back to 3. We can also insert a number in a specific location. So as you might know, with Python, we start indexing at 0. So this is the 0th number, this is the first number, this is the second number, and this is the third. So if we put something in location 1, if we put the number 10 there, then the list would look like this. So this is position 1. So position 0, position 1. So then the list would look like this. So these are a couple of things you can do with lists. Other thing that is important to mention is that in lists, you can have different data types in the same list. So we can just do this, and we can put in a Boolean as well, and print my list. So it just allows, Python allows you to do this. You can put all different data types into a single list. I think that's probably the most important things about lists I can tell you about right now. So then we can go to dictionaries. So that was a bit of a vague explanation I gave in the slides, I think. So a dictionary, it's a mapping for of key value pairs. So I made it buildings, so I think that's maybe more in your street. So I can print buildings, and I linked them to what I estimated would be the height of that building. So a house would be 7 meters tall, flat 30 meters, and skyscraper 120 meters. And sorry, if I print this dictionary, it prints just all these key value pairs as you would expect. If we want to print the value of a specific key in that dictionary, we can assign it here. So we have to present the key to it. So in this case, if I want to know what the length of the house was, I would do this. So instead of giving like an index, like the zeroth value, I want the value at the key house. So if I run this, it prints 7. Yeah, I think that is basically what a dictionary is. You can also print only the keys or only the values. So these things are called the keys, right? These strings, and the values are the integers in this example. So we can print buildings.keys, which would only print. Oh yeah, okay. This is gonna look weird, but I'm gonna convert it to a list. That makes more sense. So the keys are house, flat, and skyscraper, and the values are 7, 30, and 120. So yeah, there's a lot of things you can do here, but why dictionaries are often used is because you can search through them very fast. So imagine you would have a very long list of hundreds of elements, and you want to check whether a certain element exists in that list. You can just I should do this when I introduced for loops probably, but you can your compiler will search through that list. So it starts at the front and goes through that entire list, and when it finds that specific number that you chose, it will tell you, okay, the number's over here. And that's quite a slow process. And dictionaries have a lot of optimizations built into them that even if you have thousands of keys in there, if you type buildings and then that specific key that you're searching for, it can find that key very fast through mapping mechanisms. But we won't go into that too much. But that's why dictionaries are often used. I see that there's a question from Joppe.
Yes. As you mentioned, dictionary use those curly brackets. What are they called again?
Curly braces.
Curly braces. A list uses the block braces, or if I'm referring to the correct word. But in the functions and stuff you use to access them, you used regular brackets, and you also use those block brackets again, also to access the dictionary. I think I know the answer, but I just want to be sure. So you use the curly brackets to define the dictionary, but to access the dictionary or the list, it doesn't matter. You always use in order to state the index, you always use the block brackets, and for a function you always use the regular brackets.
Yeah, so indeed, you're right. Actually, you answered your own question.
Yeah,
So
to be sure. So
yeah, no, but you're right. So for dictionaries, we indeed use curly braces, and for lists, we use the square brackets. But for accessing any sequence, so whether it's a dictionary or a list, we use those square brackets, the square brackets. Yeah, you're right. So that might have been a bit confusing indeed. So it's not this, but indeed you need to use the square braces to access it. I think I saw another hand pop up from Leroy.
Yes. So my question is there any reason why you skip a line in your scripts every time? Because you use only the odd numbers on the lines. So every second one you skip, or is that just for convenience to make it more, to keep the overview?
Yeah, I wanted to make it more readable, but I also think it's just a force of habit that I usually. Well, this is a whole different topic that we can get into, but
yeah.
it's usually when I write big lumps of code, I try to keep things that are that have to do with each other. I don't skip lines there, so I keep them as a single block. And then if I go to a different subject, I basically skip a line. But in this case, it was, I think, just to have better oversight or something. It looks less messy, but there was no specific reason here.
Okay, thank you.
I had one more question.
All right.
Maybe you already said it and missed it, but can you also have different data types in a dictionary or only in a list?
Oh, very good question. Yes, you can also have different data types here. So I could just use this, for instance. That works fine. Or float. And then I would have to access it like this.
Oh, yeah.
But yeah, it allows that as well. Good question. I think I don't see any more questions. Then let's continue to operators. So this is quite a simple topic that we'll go through very fast. So we have different operators in Python that are also very common in math. So that's why they don't need a lot of explanation. So we have the plus, minus for addition and subtraction. We use the asterisk for multiplication. And there's / for division. This is maybe an unfamiliar one. This is the modulus. So what the modulus basically does is it returns the remainder of your division. So 9 divided by 2. So how often does 2 fit in 9? Well, 4 times, and then 1 is left. So that's why 1 is returned. Then double asterisks are used for exponential, and double / is used for floor division. So it rounds the division to an integer. Again, if there's any questions, just interrupt me. You don't have to wait. So comparison operators. These are used to compare different variables. For instance, double is sign means equal. So just let's go through this very fast because if I write 3 is 3, that is true. And yeah, that makes a lot of sense, I think. So it checks if these values are equal. Then we have exclamation mark is not equal. So 3 not is 3 would return false, which it does. Greater than explains itself, I think. Less than as well, and greater than or equal and less than or equal. These are just things we are familiar with in math as well. Then we have logical operators. And this is what I meant when I said that Python is a very intuitive and easy language, because it comes very close to actual English instead of just syntax. So if you want to check whether two statements are true, you can just use AND. As we're actually used to in math as well, we usually use all caps for these things, but it just checks whether two statements are true. Same goes for OR. It checks if at least one statement is true. So you can write an if statement. If true and false, print hello. So this doesn't print hello because this doesn't hold, right? It would print hello if this statement and this statement was true, but this one is false. So if I would do the same, but then change this to true, oh, it prints hello. And the same goes for OR. Do it again. It prints hello, but it would also print hello if this one was false, because with OR only only one of the two has to be true. Well, not is used for the reverse result, well, which makes sense. So you can just if not true, etc. Is often a confusing one for a lot of people, because what's the difference between is and is? So that is, can I make a quick example? So x is 1, 2, y is 1, 2, and z is equal to x. Okay, and then if I say x is if I say x is y, this is true because they are identical, right? So it makes sense. However, if I type x is y, it returns false. If I type x is z, it returns true. And what the difference here is that how can I say this? So when if I create this list here called x, our interpreter stores this on our computer as a variable x at some location, which has the value 1 and 2. The next step I did is introduce a new variable called y, which is stored on a different location on my computer, but has the same contents. It's also equal to 1 and 2. And third, I created another variable called z, but I set it equal to x, which means that it's equal. It points to that same location on your computer. And what is does, it checks whether the object, the variable, is actually the same one defined on your computer. So it doesn't check whether the value is the same, but it checks whether it's stored at the same location. I hope that makes a little bit of sense. And lastly, we have in, which basically checks whether a variable exists in a sequence. I can also give a quick example of that. So let's create that list we had again. So 1, 2, 3. And I can say 1 in my list. Oh, sorry about that. My list is 1, 2, 3. 1 in my list returns true because 1 exists in the list. So it checks whether it exists. And if I say 4 in my list, it's false. So I hope that makes sense as well. So those were all the operators. I hope that was a bit clear. Maybe, yeah, I hope so. Then we can go to conditionals and loops. If you've never programmed before, some of these might be a bit difficult to follow immediately. If you have some programming on the other hand, if you have some programming experience, this might all seem very easy. So I hope I found a good middle ground. So conditionals are basically what we know as if statements. So they check whether a condition holds. So in this case, it would check if a variable called a is none, and none is basically an empty value. It's nothing. It's null. I don't know how to use more synonyms, but it's nothing. So if a doesn't contain a value, then this is true and it would do stuff. Otherwise, if a equals b, it would do something else. And if both these statements are incorrect, then we would go to the else and would execute exit, which basically shuts down our program. You can also see here that at the end of all these statements, there's a double dot. So that's the Python syntax. So every function, conditional or loop, is declared using a double dot. So I can type it here. Yeah, you may have seen it before as well, but if 5 is 5, print hello. So we have to use this double dot, but because if I don't, Python doesn't know what it has to do. So a double dot instantiates like a conditional or for loop. So don't forget that. That often happens in the beginning, but it's necessary. So then we can go to for loops. So for loop basically is an iteration over a list. So this, I should have made this a list, which because now for I in range 3, range is one of these built-in functions that Python has, which returns a list with the length that you give it here. So range 3 is a list that contains 0, 1, and 2. And for all these values in this list, we print the value. So if we would run this, the output would be 0, 1, 2. Again, 0 is where we start indexing. We can also iterate over a string instead of a list. So we define a word apple, and then we can say for every letter in the word. So we can again see like, okay, this is almost English. This doesn't look like programming anymore. So we're saying for every letter in a variable word, print that letter. So the output here would be APPLE. So yeah, this all looks very very nice and easy to read to me, in comparison to something like C++, where you would have to put everything in brackets and then in curly braces to everything what contains the for loop and a lot of different stuff that you don't like, that gets messy. A question by Joppe, I see.
Yes. So in a for loop, you can also define a new variable, in this case, letter then. You don't have to define it before like you did with Word.
Yeah, so indeed. So this says we create a variable. Yeah, you're right. So we don't have to create it outside of that for loop. It just knows that the thing we're iterating over, that is called what we put here.
But Word you do have to define, because that needs to contain something, otherwise it doesn't make sense then.
Otherwise it doesn't know where it's iterating over. Yeah.
Yes, thank you.
Good question, thank you. Yes, yeah, in the preparation of these slides, I was always thinking like, okay, what is logical by nature and what isn't? So if something feels weird, just let me know, or unintuitive or anything, just let me know. And also if you feel like, okay, this is very dreadful, we understand this, like we're not children, let me know as well, and then we can pick up the pace maybe a little bit. So while loops. While loops, they are loops that continue until a certain condition is met. So for loops, we're defining a sequence over which we're iterating. So in this case, over a list, in this case, over a string. But in a while loop, we don't tell them we're not iterating over something. We're just saying that we have to execute a block of code that is inside this while loop until a certain condition holds. So, for instance, here we define a variable x and we set it equal to 0, and we create a while loop. And this while loop means that everything that's inside here is run until the condition x is less than 3 is met. So it goes into this while loop, it prints x, which the first time is 0, and then it adds 1 to x. So this I should maybe explain as well. In Python, you can add or subtract numbers to a variable, and you don't have to type x is x plus 1, but you can just type x plus is 1 or y minus is 1, which subtracts 1 from y. You can do the same with division and multiplication, by the way. So what happens here, it adds 1 to x, and returns back to the beginning of the while loop. And it checks, is x now is this condition now still holding? So x was equal to 1, so it is. So it prints that. So x is 1. And then it comes to line 4 again, and it adds 1 again. And at some point, x is equal to 3, and it doesn't execute this code any longer. So if we would run this, the output would be 0, 1, 2. Hope that makes sense. Yeah, this is basically the same code, but done with negative numbers. So we initialize y to be 0, and then we say we execute this block of code until y is larger or equal, while y is larger or equal than -3. So the output would be 0, 0, -1, -2, -3. While loops are also often used, that's why I want to present this, to define infinite loops. So you will often see when you open a block of code, you can see a while true statement. So this will basically, how do I say this? This will always be true, right? So we'll indefinitely run this block of code. But Python still has some built-in functions that can get you out of it. So you don't no longer have to define the condition that needs to hold for running the while loop in this line, but you can have multiple conditions inside that while loop that if they hold, it will break away from the while loop. So we have continue and break over here, and they do different things. So if the value a equals b, then we execute continue, which basically means ignore the rest of what is in this while loop. So skip that and just jump back to the start of the while loop. If we come to the situation that a is equal to none, then break. And what break does is just leave the while loop. So go further in your code below the while loop. Okay. So list enumeration, that's also a very nice built-in thing from Python. So if we define a list, again, buildings in this case, so house, flat, garage, and skyscraper, we can iterate over that list. We could have said like for building in buildings and then print the buildings. But using enumerate, we can iterate over that list, getting both the index of the value and the value itself. So you define index and building, and it returns the index in the list and the actual value. So if we would run this, it would give this output. List comprehension. This is also a typical Python thing that a lot of people, when they see it for the first time, think it looks very confusing. But say we want to filter a list. So we built this list, buildings, which contains house, flat, garage, and skyscraper. But we want to make a sublist of that that only contains a couple of values. So in this case, I only want to be left with flat and skyscraper because, well, those are tall buildings. So I only want to extract the tall buildings from this list. So what I do is list comprehension. So what I basically say is tall buildings is a list that consists of buildings. And so I will loop through this list, buildings, and append a building to this tall buildings list if these conditions hold. So this might be the first thing that looks a bit unintuitive. I'm not sure. Can give a quick different example. Which, so my list is range 10. Right. So if I print my list, so this is my list. And if I would say if I only want the numbers that are lower than 5, then I would do this. So low numbers list is, so I want the number for every number in my list. So if I would just do this, then low numbers list would just be a copy of this. So append number for every number that exists in my list. But I can add conditions to this. So I only append the number if this condition holds. So if number is lower than 5. So now low number list only contains this information. Hope that makes sense as well. Well, the same you can do with dictionaries. So I again defined this dictionary with buildings and their sizes, and the first method that we could use to make a list of all the tall buildings that exist in this dictionary is just to iterate over that dictionary, which we do it like this. I see that I did not introduce this, but you can iterate over a dictionary using the items function. So this returns the key and the value. So building would be the key and height would be the value. And then it checks, in this for loop, it checks if that height is higher than 10, then it's considered to be a tall building in this case. And it would append that building to the list tall buildings that we create here. So this way you could create a list of this, a sublist of this dictionary that would only contain the tall buildings that exist in this dictionary. But you could do the exact same thing using dict comprehension, which is the same as list comprehension, but then with a dictionary. So line 11 does the same as line 5, 6, 7, 8, and together. So it says tall buildings is building and height. So this is the key and this is the value, as you can see, same as here. So key double dot value. So building double height. For that same iteration that we saw here for building height in buildings.items, and only append this to this dictionary if this condition holds.